All right, given the implementation, it is time to analyze the running time of the um, algorithm, okay? So we use a recurrence to describe the running time of find maximum subarray because it contains a recursive call to itself, just like the way we did for merge sorts, okay? And we also use a simplification. And we assume that each time we divide it in half, we always have integer number as results, okay? And we assume the length is always a power of 2. So we use capital T of n to denote the running time on a subarray of n elements. Now let's look at the code again. The first line, the first if condition in which we have the smallest case, okay? The return will simply cost constant time. So that's big theta of 1. And next, the divide step also costs us constant time because it's just some simple numerical computation. And for line 4 to 5, it's to solve the subproblem. Okay, now we need to solve the left half subproblem. And the size is n over 2. So it will take us capital T of n over 2 time. Right? That's the first appearance of the subproblem's running time. Next, we're solving the right subproblem, which also takes capital T of n over 2 time. And finally, for the third problem, for the third case, special case, as we already analyzed for the find max crossing subarray procedure, it will take us big theta of n time because it is a linear running time procedure. And lastly, the code of combine is just a if, else, if, and else, which contains no loops. So it's just a constant time operation. Anyway, now we have done the analysis and let's combine everything here, right? Altogether, when n is greater than 1, then T of n consists of these 4 parts, right? Which sums up to 2 times T of n over 2 plus big theta of n. And that is the form of the recurrence or occurrence equations. So it may look familiar to you guys, right? The complete recurrence looks like this, right? The base case is constant and the recurrent case is 2 times T of n over 2 plus big theta of n. So it is exactly the same form of the merge sort. Remember the merge sort, right? Because the merging procedure also costs us constant time. So this function is the same running time. So we can simply know that the solution for this maximum subarray problem is also in this big theta of n times logarithm of n times log n, which is a more efficient algorithm than the brute force solution, right? The brute force solution for maximum subarray cost us quadratic running time. So how we solve the recurrence equation for the merge sort is to draw a recursion tree and sum up all rows for the recursion tree and sum up all the summations, right? So in the next video, we will introduce a more systematic way to solve a recurrence, okay? Which is the substitution method for solving recurrences. Of course, the recursion tree will always be useful because we will see that substitution method will require some guess on the solution.